I'd like to talk about the boot retention in the spike assembly. Over the years, we've used 3-pin bindings, and I've used the 3 pins as aid in retaining the boot in the binding. But with the development of the Spike Bulldog, we now have a pivoting plate to activate the ski brake, and got rid of the pins. You'll notice on this assembly here that we have 2 protruding pieces of metal from the sidewalls of the metal base, and those interact with the boot to give some grip to the boot when skiing. I find that one of the nice features about the pivoting toe box is that we are able to grab the boot. As you close the toe box, we're able to grab the boot with devices inside the toe box, and this clamping action holds the boot tight and gives a better performance for the binding. The boot doesn't have a chance to slide back and forth while you're skiing. Stays very snug in the binding, and the responsiveness is definitely enhanced by that. So again, in this case, we've got the built-in metal protrusions. We did make some metal cutouts. Sometimes I'll cut these off. The brake activator has some threaded holes in it there, where we can add boot retention devices here as well. My plan, though, with these protrusions or spikes is to make them removable and to also make them twist. This is the next rev of the Spike Bulldog base plate, and as you see in the red there, they're actually going to be steel. I just colored them red so they'd be easier to see. The spikes are removable. They screw in from the side, and they are quite a bit wider, so that they'll grab a wider piece of the boot sole to prevent the boot sole from wearing out. And the other feature of this is that depending on how tight we make these little units, we can get them to flip back in a disastrous fall where you would want the boot to release. I think the future of this is that the spikes could be made to mate with a specific mating point in the boot that is resistant to wear, and make that into a safety release system. These would need to be enhanced with a spring load that could potentially be adjusted to allow the boot to come out of the binding on a variety of forces. I think this would be a very simple way to make a safety release binding without adding much weight and complexity to the system. You will notice that NTN has a rounded toe box design, so that when it fits in with the toe box, there is much more opportunity for the boot to twist out of the toe box. In the case where the spike on the base plate was very effective, we would likely be able to get rid of these extra wings on the side of the NTN toe box and save some weight and allow the boot to rotate out of the toe box more predictably. .75mm Norm, on the other hand, does have a long duck bill that has square sides, and I doubt that that type of release system would be useful in this case. There are a couple of other features I want to show about the Spike Bulldog assembly. One is that there is a spring independent of the ski brake to give upward action to the toe box so that it is easier to step in. Lastly, we do have this model where using a couple pieces of plastic we should be able to develop a spring tightener so that there's a knob at the end of the heel assembly that we can turn and tighten the spring to add preload without having to move the heel. This would be a great thing to have for skiing different conditions where you want more preload or less preload and be able to do it basically on the fly. Again, I reviewed the weights on these assemblies. This assembly is the lightest one that we have, which has a short toe box, 75mm Norm toe box set up for touring, and the weight on this assembly is for a pair is 2 pounds 14 ounces per pair. And then as we add more components, NTN, the weight goes up by ounces as additional components are added. But the base weight for binding is 2 pounds 14 ounces, or 1 pound 2 ounces for the single unit.